So the move may not be reversible. Each may not be true. Each state is reachable may not be true. Each the goal is reachable from the start state. No, could be reachable from middle state. May not be true. So none of this is true. Let us go to the next question. Which water jug puzzle? 3, 2, 1 water jug ABC. ABC maximum capacity is 3, 2, 1. Okay. Currently start at 3, 0, 0. Okay. Which of the following state occur in the space graph? So 3, 0, 0. You can take this and what you can do is you can take it from here, you can pour it here in C, which is top of C, then 2, 1, 0, which is empty C in B, top of C from A. Okay. So this is true. 3, 0, 0. You can have 2, 0, 1 and then 0, 2, 1, which is top of C, then top of B. Three, 0, 0. Cannot have 0, 1, 1 because there is only 3 units of water. We cannot throw away the water. So 0, 1, 1 is not possible because 1 plus 1 is 2. Similarly 2, 2, 0 is not possible because 2 plus 2 is 4, which is not equal to 3. Not equal to 3. Okay, add page. Okay. Which of the following is true about 3, 2, 1? Okay, 3, 2, 1. And we have A, B, C. We have A, B, C. This is the capacity. So every move is reversible? No. Because if we empty it into this 2, we may not be able to come back here. For example, if we start from 3, 0, 0, we can do 3, no, we can do 1, 2, 0, but we cannot do 2, 1, 0. Not 1, 0, but we cannot do from 1 to 0. Suppose from 1 to 0 you do 1 1 1, right? Then from here do 1 0 2 1. This is 1. Or you do 1 1 1 becomes 1 2 0. You cannot put back so and get back from here. Every state is reachable, but every move is not reversible. This is false. This is true. Yeah, there's a part to 1 to 1. Yes. Let us look at this. This is depth first search. So you start from S, which is here. From S you find A, B and C. So it mentions that it goes alphabetically. It will take A. From A you will get only E. So it will go to E. From E it will get F, C, H, D. So it will take C. So it goes to C. From C it only has one place to go, which is B. Go to B. From B it has only one place to go, which is D. But D is already explored by E. Here D is already explored. So it will backtrack. It will go back to from B, it will go back to C, it will go back to E. And then so C tested. Next is D. So it will go to D. Then from D it will have B and G, so it will go to G. So this is the reason this gets stopped. So this becomes S, A, E, D, G. And the first four are S, A, E, D. Let's this. Copy it, paste. This is the next question, which I have already solved. Back to current page, SAEDG, which we just received, which we just got. Next question is breadth first search. Let's do breadth first also. This I think we can move to the previous one. We can try to accommodate it somewhere here. So this is SAEDG and this is SAED. Okay, next. So now in this one we are looking at breadth first search, not depth first. Okay, this is mentioned here. Breadth first search starts at C, starts as S. From S it finds A, B, C. It traverses each one of them because that's how depth first works. S to A, then B, then C. Then A moves to E, next node. B moves to D. C doesn't have anything because C both are covered. And A moves to C. A moves to E. From E, D is done. So it has H and F. It goes to F. D we have already covered. It has H or G. It goes to G. So it never goes to H. Now breadth first backtracks. What it will do, from G it will backtrack to S. So G to D, D to B, B to S. So the breadth first answer will be S, B, D, G. But the first four nodes will be S, A, B, C. So the question, it asks us to find the breadth first search, which is this one. So this is SBDG, right? So let's add another page. No, we don't want this. Undo. Let's copy this one. Copy this. Go to the next page. Let's paste this for reference. Let us see what's the next question. Next question is best first search. So let's see how to do best first search. Add to current page. Okay. So here S is taken as 0. A is, if you can see carefully here, 1, 2, 3, 4, 5, 6 plus 1, 7. So B is 7. This is 1, 2, 3, 4. Then you have 5, 6, 7, 8. So C is 8, Manhattan distance, right? A is, from S we have 1, 2, 3, 1, 2, 3, then you have 4, 5. So A is 5. E is 1, 2, 3, 4, 5, 6, 7, 8. So E is 8. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9. F is 9. Then 9, you have 10, 11, 12, 13, 14, 15. So I is 15. Okay. Then you have G. Let's take from here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 is D. In this case for G, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So G is 19. Okay. But G is the gold note, right? So we have done the complete opposite. Sorry, this is opposite. So we have to start with G and S is 0. Sorry. Complete opposite. Here G is 0. So from G, 1, 2, 3, 4, 5, 6, 7, 8. D is 8. From G it is 1, 2, 3, 4, 5, 6. So I is 6, right? 1, 2, 3, 4, 5, 1, 6. Okay. Then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10, right? If you go here, so you have 1, 2, 3, 4, 5. This is 5. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 11. Okay, this is 11. For C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12, right? Others we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 18. Then you have 1. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. For S, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So S is 19. So we start from S, which is 19. For best first search, you have three options. You have A 18, B 14, and C 12. Right? So you will go to minimum value 12. Now C has option E11, B14. Only two options. So it will go to E11. E has options H5, D8, and F10. It will go to H5. From H5, you have to go to D8, only one option. From D8, you can go to G. So this goes like this: S, C, E, H, D, G. The first four are S, C, E, H. Right? Let's add another page. Let's page this one. Let's see what the next question is. S, E, E, D, G. So what is the path found by best first search? Add to the current page. right? So we'll find, let's do it in the other sheet. So we have S19C12, S19C12, then we have H, then E, then D, then G, G0, H5D8, H5D8, E11, right? So you have S, it comes to C, from C it goes to, actually from C it doesn't go to H, it goes to E first. From SC to E, then from E, H, D, G apparently, while it first traverses. So E is 11, H is 5. E is 11, H is 5. So this is how it traverses. And then it finds, but then it finds the next path, which is S19, C12, E11. Doesn't need to go through H, can directly go directly to D. For it is making a loop. Then D8, then G0. Then the path becomes SCEDG without any loop. Right? Let's add a page. Let's paste it. Let's see the next question. So the next question is hill climbing. So here you have to do hill climbing. So you already seen S. S is 19. So it will go to C, which is 12. Then from C it will go to E, which is 11. Then from E it will go to H5. But from H it will not go to D. Try to go to D, but D is 8. As 8 is greater than 5, it will not go. It will just stop here. So the path is SCEH, because it always goes like this, stop. It goes in this direction. So 19, 12, 11, 5, it will not go up again. Right? This is the answer. Right? So let's add a new page. Then paste it here. And then add it to current page. We have seen that it does not find the path. It stops midway. Because it goes S, C, E, H. That's it. It stops there. So it doesn't find a path. So answer is nil. Okay. Next. Let us see what the next question is. Next question is something else, right? We don't need that diagram, so we'll move it later. Let's take this tour diagram of the genetic algorithm, add to current page, and remove this diagram. So we have this one. A tour of 12 cities is given. And let us see the question is. First is select the valid path representation of the, let's add to current page. Right, so let us start first traversal, MUSK. So MUSK OV RT PLNQ. This is the valid tour. You don't need to repeat M again, it only appears once. So this is okay. This is wrong because M appears twice. Let us see the other one. We'll look different color. KSUM. This is KSUM. QNL. PTRVO. This is also correct. This is also wrong for the K appears twice. Right? Let us copy this, add new page, paste this. Let's see the next question. The question is valid adjacency representation of the tour. So the tour given to us is K L M N O P Q R S T U V. So we will first find the clockwise and we will find anti-clockwise, right? So from K, if we go clockwise, we get O. Similarly from L, we get clockwise, we get N. M, we get U, N, N we get Q, O we get V, P we get L, Q we get M, R we get T, S we get K, T we get P, U we get S, and V finally we get R. So this is first pair. Second is anti-clockwise. So from K, if we go anti-clockwise, we get S. From L, we get P. From M, we get Q. From N, we get L. From O, we get K. From P, we get T. From Q, we get N. From R, we get V. From S, we get U. From T, we get R. From U, we get M. From V, we get O. Right? So this S, P, Q, L, T. This is the S, P, Q, L, K, T, N, V, U, R, M, O. This is O, N, U, Q, V, L, M, T, K, P, S, R. Okay. So let's add another page. Let's paste this one. Show desktop. Let's go to the next question. It is you have to convert path representation into ordinal representation. Right? This is the path representation. So we know this is given K, L, M, N, O, P, Q, R, S, T, U, V. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So K is 1. So first is O. O is 5. So it stays as 5. Then we have, let's not overlap this, so these things stay visible. I think till 5 it's fine, we can figure out. So O is 5. Then you have T. T is 6, 7, 8, 9, 10. So T is 10 minus 1 for O, so it is 9. Then you have M, which is here, is 3 minus 1 for there's no O is after here, right? So there's nothing before M. So actually it stays at 3. Then we have L and U. So L, nothing before that, stays at 2. For U, you have everything before that, right? So you have 4 things before that. So U is given as 11. 11 minus everything, 4. So you have 7. After U, we have P. P is 6. Before P, you have O, M and L. minus 3, so you have 3. Then you have k, which is the first one, stays at 1. What next? You have n, which is 4, minus. You have m, l and k. M, l and k are here. Minus 3, you get 1 again. Then you have r, which is 8, minus. So you have k, l, m, n, o, p. You have everything up till p except q, right? So you have 1, 2, 3, 4, 5, 6 elements. So you get 2. Then we have v, which is 12. It has everything before this, so everything which we have traversed till now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So minus 9, it is 3. Then we have s, which is 9, minus everything till now except t and v, except tu. So tu we have covered. So t, u and v should remove. How much we have got? We have got 1, 2, 3, 4. So t and u should be leaving. So 1, 2, 3, 4, 5, 6, 7. 9 minus 7 is 2. Then we have q, which is here, which is 7. Before 7 we have k, l, m, n, o, p. So you have literally everything. So the output should look like 5, 9, 3, 2, 7, 3, 1, 1. Then we have 2, 3, 2, 1. This looks like this one, right? Okay, let's add another page, right? Let's try to paste this one again, and let's go back here. Oh, it's a new question, so we have to take a new picture. This is the question. Add to current page. We can delete this one. Let's keep this one, and let's go to the question. So the question here is, enter one of the child words, right? And so let's take a picture like this, so that capture question and the solution. Take a picture like this, and add to one page, and we can delete this one, right? So we want to do a PMX, partially mapped crossover. So we have P1, MUSK, OVRT, then we have PL and Q, then you have P2, OT, ML, UP, KM, RV, S, I think it's Q again. Okay, and it says these 4. So the first child one is copy everything here. Let's make it OTML. Then we have OVRT. Then we copy everything here. We have RVSQ, right? But we have O here. We have T here. We have R here. V here. That's it, right? So we replace O with U. Yeah. This becomes U. T becomes N. UM. M stays as it is. UNML. OVRT. R becomes K. V becomes P. And S becomes stays S, and this is the child 1. Similarly, child 2, here you copy entire thing from here. So you copy mask, then you keep UPKN, then you copy PL and Q, and then you see what overlaps there are. So you have U and K, right? UK, and you have P and N here, right? So let's keep M here. U is becomes O, right? It becomes O. S, K becomes R. Then stays as U, P, K, N. P becomes U. P becomes V, right? L stays L. N becomes T. This stays as Q. This is a child too. So this is, as you can see here, M O S R U P K N V L T Q. And this is U N M L O V R T K P S Q. Right? Let's go back to desktop. Let's see the next question. So here we have been given a this matrix. Let's go copy this and paste it in a new page. Previous one was solved. Let's put it in the top here and then try to look at the problem. What's the problem? It says start from city C and construct a nearest neighbor heuristic. So you start from city C, right? So if you start from city C, the smallest number here which you can find here is 29. So you use 29 and you go to E. Then in E you find the smallest number is 26. So you use 26 and you go to B. Then when you get to B, then the smallest number is 15. You use 15, you get to D, right? So B, C, D, E starts from C, B, C, D, E. From now D, you have to go to A. So we are now in D to A, it's 13, right? You spend 13, you get to A. So from C, the smallest number is 29, you go to E. From E, you go to, okay, sorry, from there is 25 as well. So there is not 26, there is 25 as well. Let's double check here. So from E, the smallest number is not 26, it's 25. So you do 25, you go to D. Yeah, now from D, the smallest is 13. You go to A, and from A, the smallest is 13, you have already done. Then you have 59, which is F. 59, and then from F, you have to go to, because only B is remaining, and B is the smallest as well by chance, so you go to by 22. So the path here is C, E, D, A, F, B, and you are done, which is this one, right? Let's copy this, copy board, copy, add a new page, let's go ahead and paste, and then the next question is cost of tour generated by the nearest neighbor heuristic. Okay, let's see what's the cost of the tour. So what we have done before is that we have gone C, E, D, A, F, B, we have gone C, E, D, A, F, B. So C to E is 29. No, C to E. C to E is 29, yes. 29, which is C to E. Then from E to D, it's 25. Then from D to A, it is 13. And from A to F is 59. From F to B, it is 22. And then you have to go back from B to C as well, right? Then you add B to C. From B to C it is 74. So add 9 plus 5, 14, 3, 17, 9, 26, 28, 32, 2, carry 3, 3 to 5, to 7, 8, 13, 15, 722, right? It's 222. Let's create a new page. Let's go ahead and paste this chart again. Let's go back to desktop and let's look at the next problem. It says find the constructed tour using greedy heuristic. Okay, so let's see what the greedy heuristic gives us. So greedy heuristic, the smallest edge is AD, 13. Then you have BD, which is 15. So now two D's are done. Then you have BF, 22. So 2B and D, both are 2B and 2D are over. Then you have DE, which you cannot take because D's are gone. We have BE, which you cannot take because again 2 B's are gone. Then you have CE, which you can take, 29, right? So now these two go away. You have CE 29. After CE you have DF, cannot take because 2D are gone. Then you have EF, which you can take because there is only one. You have EF, which is 52. So with this we have now two E's as well, 2B, D, E and F all as well, right? Just see in any loops, BF, CE, EF, FE, EC, no. There are no more loops formed, right? So we have A, B, C, D, E, F, almost all covered starting from C. So let's look at what we have got. We have got AD, BD, BF, CE and EF. That means across E you have C and F, but we need one more. So it starts with C, right? So if it starts with C and it stays F, this takes care of these two. Then from F you have B, then you have D, then you have A. Then you can also say this again, C, E, A, D, B, F, E, right? C, E, F, B, D, A, C, A, D, B, F. Both are the towards possible, which are the answers here, right? Let's go to the next question, which is this one. Add to new page. We'll need to paste look again. It says cost of the tour generated by greedy heuristic. Okay, the greedy heuristic generates AD, I guess BD. Or let's go in this loop, for example, CEF BDA. Let's go like this, CEF BDA. So you have CE, which is 29, plus EF, which is 52. We have FB, which is 22. You have BD, which is 15. We have DA, which is 13, and then A goes back to C, right? So we have to go back to C as well. You want it as AC as well. So the AC here is 96. Sum total is how much? So we have 9 plus 2 11, to 9 to 11 to 30, 9 plus 2 11 plus 2 13, 5 18, 21 6, 27, 2 2 to 4 5 9 to 11 12 13 9 22. We have 227, right? So let's add another page. Let's paste this again. Let's look for the next question. What it says is the last question. It says take C as the Falcon node and compute our two missing values. Let's add to current page. Let's take C. It says take C as the fulcrum node. Okay, so if you want to find savings of AD with respect to C, this will be D of CA plus D of CD minus D of AD, right? What is D of CA? It's given here, 96. What is D of CD? It's given here, 60. What is D of AD? Given here, 13. 6 minus 3, 3, right? 9 plus 6, 15. 15 minus 1, 14. It's 143. Make sense? So this is 143. Similarly, if you want to have savings of BD, you have to find D of CB plus D of CD minus D of BD, right? So you have CB is given as 74 plus CD is given as 60 minus D of BD is given as 15. Make sense? So you have 14 minus 5, 9, 6 plus 6, 12, minus 1, 11. Make sense? So this is 119. Now we put them again in decreasing order of savings. So top one is 143 AD, we have 119 BD, then is 106 BF, and then we have next highest is AB. So by this 2D and 2B gone, AD, BD, BF. So can we add AB? No, because 2B is gone. Can we add AF? Yes, we can add AF. AF is 91. Can we add BE? No, because 2B is gone. Can we add DE? No, we cannot add 2DE because 2D is gone. Can we add DF? No. Can we add AE? No, because 2A is also gone. Let's look for any loop. BD, BF, AF, AD. Okay, no loop still now. AE is 48. Can we add AE? No. Can we add EF? No, because 2F is also gone. So we cannot add. EF31, AD, not. Again, this actually will become a loop. AD, DB, BF becomes AF, so this won't be there, so AF can't be here. This becomes a loop, so AF goes out, so we'll not have 2AF here. 2B stays, this not be there. DE, no, 2D is gone. DF not possible. AE is possible because A is still available and we have only one F. EF is also possible because we have one E. But we have one F. We have one F here, one F here. So let's list it down just to see if we are not repeating anything. ED, BD, BF, no AB, no AF, then AE and EF. So we have two Ds, two Bs, two As, two F and two A. Yeah, we are good, right? We start from C. So we have AD and BD. That means We start from C and we have AD and BD, so you have A and B around D, and we have A and F around E as well. We can have something like this. So A becomes common, then you have C, B, D, A, E, F. This becomes C, B, D, A, E, F as one part. But then F and B don't work together. So F has to be around B and E. So this path fails. So let us see if we can do F around E and B. Okay, write F, we have B and E. Let's write D, it has B and F. Then both of them are not possible. Right? So that means we don't need this. We can do it with till here only. Right? So how will you do with this? We have D, A, B, then you have F, but before A you have E. So you have E, A, D, B, F. E, A, D, B, B, F. E, A, D, D, B, B, F. And you can add C in front. Other one could be C, F, B, D, A, E. Both works. We don't need EF. Okay. So that's the last question, I guess. Yeah, that's the last question. So let's go back and let's start.